not understand where energy comes from or its role or how important it is. My concern is not that we're going nowhere, but we're not going fast enough. Most organizations reward conformity. Are the inputs to your system more expensive than the output? Within projects, I think the milestones, first of all, they have to be quantitative, eliminate the bureaucracy of the systems going forward. How do we end up with fast funding of projects? How do we have the ability to fund projects really based on an opportunity?
Doug Wicks is a kind of a guest that makes you smarter just by listening. He's led industrial innovation from the lab bench to the policy desk, turning waste into energy and skepticism into investment. And after 6 years directing programs at ARPA-E, he's now on his next chapter, a free agent, the strategic advisor, figuring out the next adventure. So basically, he's the Liam Neeson with the chemistry set. This conversation goes deeper than our last one, so let's get into it. Doug, for the second time, welcome.
Thank you, Ernest. Looking forward to it.
I've got to ask, when you think about everything happening in the energy right now, why does this matter so much to you personally?
I'd have to look at it, and one of the reasons that I want to stay active is there is huge challenges facing us, and I really look at it and say that the firm, reliable energy is really the foundation of our societies. As we go forward, and doing that in the best way possible is really very important for a society, but more importantly, the next generations to say, how do we address energy in a way that doesn't impact the environment, is good for society, and yet allows, for proper economic development and really national security. Especially for during the current times.
And what is blocking us on this way?
I think, and I think a lot about this. I'd have to say there's a big challenge out there that people do not understand where energy comes from or its role or how important it is. And that tends to allow us to be distracted by short-term issues around the system, around the energy system, and not understanding that role and appreciating that role. I mean, the fact that our lights stay on with no issues, a generation ago, that wasn't there. It's becoming more and more normalized, and with society not understanding that, and our governmental policymakers, shifting back and forth on the system, really creates challenges going forward that we're going to run into some brick walls coming up.
Yeah. Knowing what you now know, how would you solve this if you could?
How would I solve it? That's a huge question.
Yeah.
I think that, again, coming back to that environmental, social, and economic methods, it's really coming back to say, let's develop policies that will last, in the democracy beyond the current politician. Is how do we develop those long-term investments, that allow us to do this? This is very difficult in the United States. Europe has its issues as it swings back and forth. You look at Germany, they're screaming for clean energy, and at the same time, they shut their nuclear plants down. Not thinking about the fact they're going to be importing high CO2 fuels or electricity from other regions. And now they're swinging back saying, let's reopen again. And the pendulum swings too much in the way. And that's a challenge.
And somehow it feels like we're going nowhere.
No, I wouldn't say that. I think there's lots of progress out there. There's lots of good work that can be done. My concern is not that we're going nowhere, but we're not going fast enough to where we need to be. We have the solutions, and we've just chosen to either slow walk them or ignore them.
Yeah. So before we go a little bit back in time, what do you think are these solutions?
What do I think the solutions are? That's a deep question. I think the solutions really have to be is how do we effectively develop the subsurface? I look at the fact that really all of our energy comes from the subsurface in one way or another. Whether it's the hydrocarbons that power the vast majority of our current industry, our current energy system, whether it's the emerging topics around geothermal and enhanced geothermal, or the potential that I work heavily on of natural hydrogen that we talked about before. These require serious engineering, in the subsurface. They're all very much related. And then you bring in, and some will come back and say, well, we have solar and wind. All that infrastructure, again, comes from the subsurface. We have to mine the minerals to do this. And I think a really major effort, has to be made specifically in the West to say, how do we engineer the subsurface in such a way that we can get the energy we need out of it, or the sources of the energy to go forward. And they're all related. All the stuff in the subsurface. If we could take the developments from oil and gas and put it really to enhance geothermal like Fervo is doing now, if we can put it into hydrogen production, if we could move this into mining, we could have incredible improvements in productivity while at the same time reducing the environmental and social impacts of development.
So at what moment, or maybe a conversation that first sparked your belief in mining as a tool for solving the energy crisis?
It's pretty funny. My background, as we've discussed, is not mining or minerals. I'm actually an organic chemist by training, or polymer chemist. The vast majority of my career was spent in the polymer industry, or research and development around that. And it wasn't until I really joined an industrial minerals company, that didn't mine the metals or the coal or oil, but really the fundamental minerals that make up a lot of the stuff around us, and began to look at it and say, wow, this really hasn't changed a lot, since the time of the Romans. If you begin, you really begin to look at it, We approach most mining techniques the same way the Romans did.
Yeah.
Yes, we've had some advancements, and the more I thought about this lack of progress, the more ability I saw for innovation, and then
Yeah.
began to, as we did an exercise within that company looking at the grand challenges facing mankind, it became quite clear that mined materials were going to play a key role in that going forward.
Yeah.
And that really brought me into the idea that really, if you want to address anything, you have to address mining.
Yeah.
And bring it into at least the 20th century. It's not
Were
the
you
21st.
were you always someone who challenged the system from the inside, or did that mindset come later?
Um, I'd have to say that that's something that developed fairly early in my career, and um, I can still remember advice that I got back in early in my career when I was working in large industry, and that's somebody took me aside, and a mentor took me aside and said, "Never need your job. You need to work.
Wow.
Because if you need your job, you're going to toe the line of
Yeah.
your employer. And but if you look at it and make sure that you position yourself either through good economic planning or through making sure you have other opportunities in place,
Yeah.
that you don't need your job. I need to work. That's
Yeah.
throughout my career, I was not born phenomenally wealthy. So I needed to work, but I always made sure I didn't need my job because then I'd be afraid to say what I thought.
Yeah. Wow. Great lesson. When you pushed hard the rock mining into DOE spotlight, what were you risking?
Um, for me, not very much. Again, personally, I could have walked away from the job at any time. Um,
Yeah.
it was the risk was really uh, the risk I'd have to say was if I was not successful in convincing them that was an issue. Um, Early on, I started talking about mining and minerals, and the pushback came and said, "Oh, that's not an issue. That's old technology. The miners will respond to the market signals and take care of all that.
Yeah.
Nothing we can do to fund big breakthroughs in the area." And that was very concerning to me. Because, again, I kind of looked at this topic and said it was an area that needed innovation. It needed
Yeah.
really a complete rethink. And it took a long time to get to get really a full program out in this space. To say that we want to do this. There was lots of pushback, a lot of saying, "I don't understand why we would do this. Why doesn't the mining industry do it?"
Yeah.
So personally, I didn't have a risk. As I say, I could have changed jobs.
Yeah.
And
But you stayed there and fought. So you've backed some bold teams like Phoenix Tailings. What do you see in them that others often miss?
I really like. Some of the companies some of the companies and researchers I back is they come at it with a radical new thought,
Yeah.
and then show really some inspiration to get the job done. And what I liked about Phoenix Tailings was it was quite clear from their initial application, which came in as a small business innovation request, um, that they were doing something very different. And at the time, one of our fellows, ARPA-E has young graduates coming in,
Yeah.
Christina Chang, really, highlighted it to me that this was different. And when I read the proposal, we were looking at it and saying, this is something very different. The objectives they're addressing
Yeah.
is to do something, and they're taking personal risk to do it. So these people at the time were doing, literally doing the initial development in their back porch
Wow.
of their house to do the proof of concept. And so that gutsy approach that I'm going to do it completely differently. And and I see this in other companies that we've funded. It is how do we do it, different and actually really start. You can tell that they've already started to work on their own, putting a lot of personal risk on the line to do it, which I think
Yeah.
is an important thing to say.
That always means something. Uh, Forgive me if this sounds naive, but how do you know when a radical idea like, say, Rock Zero is actually ready to leave the lab?
How do you know? And um, yeah, I mean, Rock Zero is another one of my favorite ones, which was a totally crazy idea to look at it. And it became very apparent early on when one of the founders, Camden, who was working for Yet-Ming Chang, um, really kind of laid out the first practical process of testing. So not just testing it, but then coming back and saying, well, if we did this, how do we recycle? How do we recover? How do we make it efficient? And it was very early on. So I would say from concept to literally base concept to spin out um, was basically a year. From a radical new approach. And the progress they're making now, I mean, really tells me they're going to be in the field, um, testing real systems at real processing activities, within the next year. And you kind of look back on that, that's 3 years from concept to going. And it's, it's hard to say sometimes what lets you know that, other than the fact that it's, you look at it and it's elegantly simple.
Yeah.
And I think we tend too many times to want to go towards the super complex. And I run into this in ARPA-E. People are like, well, that's too obvious. Of a project to do, and it's like, well, nobody's done it. Nobody's done it, and it's incredibly straightforward. It's this new paradigm of connection of material works. Why not run with it? And it's and I saw that in Rock Zero quite clearly, and again, I saw that in the work that Phoenix Tamming has done, and several of the other companies have backed. In small business or in academics, that you just look at it and say, it's a radical departure, but if you keep it simple, it will have a huge change.
Yeah. Can you take me inside your process when you meet a new proposal? What's going on in your head as you weigh the risks?
Well, typically, I'd have to say at ARPA-E, that a lot of times before proposals come in, you've actually talked with the submitters. You've met them through conferences or workshops or industry days that we have. And so a lot of times I'm looking at it saying, are they fulfilling the potential of the process?
Hmm.
And and I will look at it, and and I have funded a number of teams where they've talked about doing a process, and I saw something in there that they did not capture in the proposal. I looked at it and said, wow, if you have this idea, with a flexible person, um, you could actually radically change the process going forward. And an example that I give around that is, Eden Geopower, that we funded them. This is an electrofracturing company. As their line says, they break rocks. They came in for a topic on geothermal, enhanced geothermal processes. And I kind of looked at it and said, wow, this is a tool that, again, coming back to that engineering of the subsurface, has wide applications across many fields. And so when they got funded and moved forward, they did broaden it, and they've been challenged by some people to say, well, you're too many topics. But actually, it's the same technology: geothermal, enhanced oil recovery, mining, geologic hydrogen production. It's how do you use this tool across many different opportunities.
So you've seen ideas go from slides to scaled factories.
Yeah.
What's the part that usually breaks?
A lot of times it's the leadership of the project. I mean, I emphasize to my teams that if you want to move fast, you need the right people to drive this. And it might not be the inventor. In most cases, it's not. And I've seen really good ideas, get really stifled, because the inventor won't walk away from it, and let people do things. They have their own vision of what should be out there, and if people try to deviate from that vision to something more practical, they get in the way. And during my time in startup industries, I spent a number of years in venture capital-backed startup companies, and really, there was the great word of founderitis, sickness in the company of the founder not letting go.
Yeah.
And
that's pretty common.
Yeah, so I mean, the major failing, I have to say, for a really good project is not bringing in the right.
And when you're looking at impact versus investment, what's your internal equation?
I mean, I really kind of look at it and say, and this falls into the guidelines that we used to have ARPA-E, which is you have to look at, would it impact, if successful, 1% of the U.S. energy impact. So coming back to say, if you're successful, would you pick it up without having to go to a decimal point in terms of impact? And you see that same thing reflected in some of the big energy investors, or big venture investors in the space. They want to have a equivalent of a gigaton of CO2 impact, or start talking about quadrillions of BTUs of energy, either displacement or augmentation.
If we were designing a program from scratch right now, what are the 3 ingredients you'd say are absolutely non-negotiable?
A program overall? I would have to say that impact has to be more important than the science. Science for science sake is great. People fund that, but according to design a program, that the impact has to be there. The second part of it is you have to look at it from a techno-economic standpoint to say that in the absence of subsidies, it is going to be competitive. It's going to bring something out. If you're relying on subsidies or government policy, it shouldn't drive your activities. And the third thing about designing a program is how do you run fast and fail fast? So that how do you speed stuff up? I mean, I talk a lot about how slow government is and likes, and it really, slowing down to make sure you're not being cheated results in you wasting a huge amount of money. This is, we're trying to be penny wise and pound foolish, as they say.
So, what happens behind the scenes when a promising idea just isn't delivering? How do you make that call?
The way programs are structured in ARPA-E, each project has, milestones and objectives, and they're rated on that quarterly. On a green, yellow, red light system that comes back, and the defunding process really comes down to when you say the technology is not going to work. So this is a discussion with the principal investigator to say this is not going to go. And there are some who look at you and go, "You're right," and you ask them if they have another idea that would be worth funding, and if they don't, you terminate the project. I pivot a lot of projects. You look at it and say you're not meeting the initial objectives, but you've opened up an opportunity that's just as impactful as the primary one.
And I know you emphasize Plan B thinking, but why is that so critical in this space?
Well, again, from the government standpoint, is the amount of time to get someone funded is ridiculous. And if you have a great team, why would you fire them and tell them to apply for something else? And if the project fails through no fault of the team that's working on it, some things are just designed not to work. And you've put together a good team on something. And I'll say Rock Zero, when you brought up earlier, that is a pivot. I mean, that's a project that was a complete deviation from the previous funded activities. And it just became apparent, looking at this saying that, okay, we'll rewrite your objectives from a new program. And I mean, when I look back in industry, that, my industrial experience, you also have active project management. You're going to cancel projects and the likes. When you cancel a project in industry, you don't fire the researchers. You put them on another project. And the way we run our programs in government is the moral equivalent of, if a great team took a risk and was not successful, we penalize them by firing them. And put them back into a bureaucratic grinder to get something else done.
So I'm curious, when you reduce someone's budget, by 50%. How do they respond, and how do you justify it?
Yeah, I mean, a lot of times, I mean, I have the advantage of having a lot of experience in academia and startups and big companies. So part of it is I can spot BS when I look at it.
Yeah.
That they're just padding their budget. And the down selects also are a lot of times we remove major tasks and objectives because it's not their strength. We do that. And you can carve out, they're trying to fulfill all the parts of it. And you come back and say, well, this is what they're really good at. And I have somebody else that's really good at doing the other tasks. So let's cut that out. And for the most part, you do get some griping. I will say nobody's happy with this. And I have had people say, we can't do it for this money. And it's like, okay, I know somebody else who wants the money. And then quite suddenly they can do
it. So you have to be a good negotiator too. Yeah.
You have to be tough, and you have to be able, you need to be in a position to walk away from an idea that somebody's doing. And, again, it's coming back to that opinion. You don't need that project in your portfolio. It would be great to have. But if it's not going to work out, give it to somebody else.
And how many of these projects in percentage are really successful,
Well, there's different definitions of success. And so I would say
survive.
Meeting the objectives of the projects, a lot of times they're 75%. So about a quarter drop off.
Wow.
And, which is too high. And it should be lower than that. The ones that are truly successful, that have, that meet the expectations of the program. And by the way, those 75, those percentages, I mean, they're doing good work and are contributing, but they're not leading to major changes. I would say the ones that end up doing transformational work, 10 to 15%.
Wow. So
I mean, truly transformational will be selectively.
That's fair. So there's a fine line between guidance and control. How do you know when to step in and when to back off?
If they're knocking my socks off, I don't have to do any control. I just look at it and say, wow, this is what you're doing. In these quarterly meetings, I am very well known for making suggestions. And most of the teams respect my suggestions. The occasional team doesn't listen, and those are the ones that are 25% that are going to fail. So I mean, if the project's not making progress, we will take impacts, and people know that we're going to do that. So they tend to continue processing going forward, and some teams you have to work a lot with, because you're not picking up the sense of urgency, especially on the academic side. That you have to get quite involved, especially from the tech to market side, saying, let's drive patenting, let's drive discovery. Don't worry about publications.
The phrase bureaucratic inertia comes up a lot. How did you manage to get things moving inside the system that resists movement?
Persistence. Again, launching the mining program. I mean, if I look at my
Yeah.
two big projects, the two big programs, and that's in the miner and the geologic hydrogen. I mean, those took years to get approved. Literally. I mean, just conceptually to go forward, I had to give multiple presentations. And the lethargy of the system is quite an issue. And by the way, bureaucracy is on both sides of the table. So you have the bureaucracy of the government running into the bureaucracy of the team that's doing the work. And I was quite well known for having the personal cell phone numbers of my team leads and the bureaucrats, especially in the academic, the bureaucrats above them, such as the VP of research. And I was quite well known for saying, if you don't do this, I will cancel the project. And especially in contract negotiations, people have all types of things they want to change. And you basically say no. There are people who want the money. If you don't want it, you can negotiate away as much as you want, but I'm not going to wait for you to negotiate. So we'll terminate the negotiations if you want to do that. This hill you want to die on is so important. And it's amazing how fast insurmountable objections, apparently insurmountable objections, are overcome when you say, okay, we'll walk away. And again, it's that philosophy that in negotiations, you have to be willing to walk away.
Yeah. So did you ever feel like politics got in the way of what you were trying to do?
No, I mean, we're quite lucky. I was quite lucky in being at ARPA-E, that it's really a bipartisan support is very high in the topics we work on for the most part. Didn't attract any negative attention. And we kept to the directions in our founding authorization, which was focused on reducing imports, improving efficiency, and reducing the environmental impact of energy deployment. And so we didn't swing back and forth, with the congressional rooms.
And now when you look back, what moment changed the course of your career forever?
Oh, lots of them. I have changed my career many times. As I like to tell people, right now going into probably my 7th career. It's going to be totally different than anything I've done before. So it's really, it's hard to come back and say what's changed, my career choices. I am very lucky to have a very supportive wife, spouse who, keeps me level, and tolerates these, every 6 years me reinventing myself. And literally it goes back, if you look at my career, it's every 6 years, completely change direction.
Wow.
And, so, I mean, I pretty much knew when I came up with the end of ARPA-E, I was going to be changing again. And she did put her foot down this time and say, no, we're not moving. All my other pivots had us move.
Wow. Wow, that's adventure, like in both your professional and private life. But when you look back, how does it feel? Do you regret any of these changes?
No, there's I've got lots of scar tissue from some of them, but all of them, were done, um, really out of curiosity and a
Yeah.
willingness to learn. I've shifted fields many times, so no, I look back and everything I've done in the past has um, led me to where I am now and given me the ability to look at things very differently because of my diverse background.
And do you think that the system is designed to reward people like you, or did you have to bend the rules to make impact?
Um, I would have to say that most organizations reward conformity. So paying attention to the rules, and I'll take my most recent role since it's at ARPA-E. That there is a process to make sure your project gets really approved very quickly, and something I really wasn't very good at. I like to call it is really a kabuki dance that you have this entire, really, you do this entire process and the outcome is already known. And I didn't have a tolerance for that. So pretty much, avoided, doing things the normal way and tried to go into areas, that were true white spaces rather than just building to areas that had been investigated before.
And how do you personally handle uncertainty, especially when millions of dollars and people's careers are at stake?
Oh, I don't know. Uncertainty is what you want, because if there's a lot of uncertainty about what you're doing. Well, there's two types of uncertainties. I think about that. And one is maybe evidence through the changes that have been taking place currently in the U.S. government, but there's a lot of unknowns.
Yeah.
I think what you really have to do during those times is just do your job. And I get all types of questions from teams that we were funding. What does this mean? What's happening? And my uniform comment to them was, don't pay attention, just do your job. You can't influence what's going to happen.
Yeah.
At the macro level. And in terms of but the other thing that's good about uncertainty is when you're jumping into a white space. The more uncertain you feel, the higher probability of a breakthrough you have. That makes sense.
Yeah. Yeah. So imagine someone's listening right now and they want to enter this world, to fund radical solutions, to shake up the old system. What's the one thing they need to know that no one's really telling them?
What's the one thing they really need to know that no one's telling them? There's a lot of people telling them a lot of things. I think what the thing that they need to do, which I put into a lot of my talks, is if they're going to be funding crazy research, is put it in the global context. Say, what is it going to be meaning? If you're coming back and saying, we're going to, if successful, we're going to eliminate hydrocarbons. I'd have to say, if you look at it in the global context, no, it's not going to happen. And understanding how big complex these processes are, is important. And I start out most of my university talks with the total energy consumption of mankind over the last 150 years. They come back and say, let's put this in context of the size.
Wow. And what's something you used to believe about the energy innovation that you no longer think is true?
Well, I mean, I can say that really up until really joining ARPA-E, I just took energy for granted. I was pretty energy blind, about where energy comes from. And now I believe that we have the ability to really change that. And I guess when I started at ARPA-E and somewhat within industry, the question was, radical changes in hard tech can't happen fast. It's going to be a slow evolution of processes.
Yeah.
And I think now, after 6 years at ARPA-E, and actually seeing companies that I've literally funded towards the beginning of my time already in commercial production,
Yeah.
comes back and tells me that, hard tech can move right with the right support and the right people.
Yeah.
And, so, which gives me a lot of hope, by the way, because it tells me that, we can innovate our way out of this.
So, what program design elements proved most effective at catalyzing transformational change?
The program elements, I have to say that the most important thing when you put a problem out is not to dictate the solution.
Yeah.
And I mean, I always say when people ask me, how would you do this? I go, I don't know. I'm a program director. And I know what the problems are. I don't know what the solutions are. And I think many times within these types of systems, we tend to prescribe the outcome.
Yeah.
The metrics sort of look like this and this and this, rather than saying, this is what we want at the end. How you get there is not an issue.
So, what strategies ensured a diverse and competitive applicant pool?
One of the things that ARPA-E does very well is we publicize a lot. So, within my areas, so let's take geologic hydrogen as an example.
Yeah.
If I looked at the performer pool 4 years ago, there was 1 or 2 universities in the United States that thought about it as a power source. There was 1 company working in the United States. None of the national labs were involved in it at all. And so the one thing that you really have to do is talk about it. And I probably, before my funding opportunity came out, I probably gave 40 to 50 talks on that reflected my program evolution in my mind. At universities, at conferences, and at the ARPA-E summit, to begin to socialize the idea, and then holding workshops. ARPA-E is very well known for its workshopping of ideas. By the way, also coming into the natural hydrogen space, I gave 40 to 50 talks on it, but I probably had 200 phone calls.
Wow.
And,
And
a lot of those, you had to convince people to get interested. And I was pleasantly surprised how many people applied for it and how diverse it was.
uh, how did how do you develop realistic early stage economic models to justify the funding?
Well, I mean, it's, you know, a couple of ways to look at it. First is the real obvious, is to say, um, are the inputs to your system more expensive than the output?
Yeah.
So if, there was a great discussion one time, a great analysis on one time about a process where somebody said any engineer should have looked at this process and said it was moral equivalent of making sawdust out of mahogany tables. Your incoming products were more valuable than intended. So look at hydrogen. Let's look at hydrogen, for example. Um, and a lot of work was done on electrolyzer hydrogen, the so-called green hydrogen. And you look at it and say, and everybody said we're going to get to $1 a kilo. And then you say, well, we need 40 kilowatts of power into it, at a thermodynamic minimum. Either be electricity or thermal plus electricity, but you still need that energy. And what's the price of electricity? And it comes back in and says, there's no way you're going to make it just based on the price of electricity. Which people calculated 5 years ago, and nobody listened to them. And now we're in the midst of a green hydrogen collapse. And with natural hydrogen, the processes we did is we really came back and said, the best comparison is going to be tight natural gas in the United States, and kind of took their processes and really tried to come up on a volumetric basis. What if everything worked? What would the rough cost be? And we were able to estimate that fairly well from the beginning. And the inputs are very well known. Most come from the oil and gas industry. And the only variable that had to be dealt with was yield. If you're stimulating it, what's the output going to be? And if it comes back to that as being an engineering, then you say it can be solved. There's no law of thermodynamics that we had to beat.
And what best practices ensure clear targets and milestones for funded projects?
Within projects, I think the milestones, first of all, they have to be quantitative. So if you actually have to come up with some physical, something you can measure and say we've gotten, rather than say we're going to investigate this reaction. And it's like we're going to investigate this reaction and get the following outcome that we measure. That's really the most important part of it, is making sure it's measurable. The milestones should also be aggressive to push people to work hard to solve. That if through no fault of the performer they can't be met, you have it up and to say we're going to pivot or adjust as required. But really make them aggressive such that the team wants to work hard.
So, how did you leverage public speaking and thought leadership to shape energy policy?
I don't know if I can say I've affected policy. we'll see if policy follows where I went. I think the presentations made people think about new technology areas, and it impacts not only the groups I talked to, but also other areas. So again, looking at natural hydrogen, was an area that no one was working in,
Yeah.
and now in the U.S. We are clearly in the lead because we have large numbers of people looking. And some of the other ones that I talked about that go back into my one of my other great interests is how do we use everything we dig out of the ground. Dirty secret about mining is we throw out more than 99% of what we dig out of the ground, and
Yeah.
everything we're throwing out is being mined somewhere else. So this concept of how do we do what I've termed as mineral distillation, where we fractionate it and everything has use, what they do with a barrel of oil. A lot of those talks have taken place, and within even now the large mining companies that coming back and saying, how do we valorize much more of what we take out of the ground is beginning to take hold. So that, just talking about things and soliciting input and comments will shift, what we're thinking about.
And how do you bridge the gap between academia and industry?
Well, having done this several times myself, I say it's first and foremost, when I look at the academic work, is how do we drive it and make sure that there's an entrepreneurial spirit about it. One of the things we did with the mining program and we've done with geologic hydrogen is really integrated in student entrepreneurship training around it, which again was quite controversial within ARPA-E when we started it, to come back and say, let's take all the mining programs and try to train people into entrepreneurship around their project so that they think about it as a product instead of a scientific project. And that helps that transition and helps with spin out companies that take place out of this. And you can see the impact of the spin out companies coming out of this, which is quite good. So in many of these totally new areas, you really need somebody to go out and champion it outside of academia to do that.
And tell me, if you had a magic wand, what would you change about ARPA-E?
What would I change about ARPA-E if I had a magic wand? I guess the first thing would be to come back and say, how do we eliminate the bureaucracy of the systems going forward? How do we end up with fast funding of projects? How do we have the ability to fund projects really based on an opportunity and do it quickly? Within ARPA-E, we hear a lot of ideas, and you just look at it and say, wow, I wish I had a program I could put that into. And we have generalized solicitations that come out, but they tend to come out several years apart from each other, or result in a highly bureaucratic process to get it funded. And, and a lot of times that bureaucracy slows it down. The other thing I would change, which is somewhat different, think about, and that's the leadership of ARPA-E. The interesting thing about our office is the head of ARPA-E, who was Evelyn Wang, prior to this, has to be confirmed by the Senate. So it's nominated by the president. The person nominated has to go through a nomination process. And what this results in is large portions of time with no leadership, no direct leader of ARPA-E. We have acting leaders, and they tend to avoid controversy, tend to try to not do anything. They don't want to rock the boat. So if I look at it, during my tenure, Evelyn Wang really only had 2 years in charge of ARPA-E out of the 4 years that President Biden was in office. Before her, it was Lane Dematowski. And again, Lane was held up in the confirmation process and only had 2 years. So half the time, ARPA-E is not forging new directions in place. And this is in stark contrast to DARPA, who's a model reactor. The head of DARPA, which is 10 times as large, is not a Senate compliant position. So a person can come in with a new administration and have an impact very, very fast.
Yeah.
So again, it's that bureaucracy of government. And by the way, there has yet to be, in the entire 16-year history of ARPA-E, probably half of that time we did not have a confirmed director. But also during that time, the Senate never voted against any of the nominees.
Wow.
So it's a filter that never is filtered in.
And how much actually can these leaders impact, the way it's being led and the structure and everything else? Are they under the pressure of the politics?
In many ways, they are at the when the president, they're serving at this level. They can have large impacts. Again, if we want to reduce bureaucracy within the system, if we want to change the way projects are evaluated or the likes, in the absence of somebody making a firm decision, we just do it the way we always did it. We have a caretaker in place. So they can have an impact. They're also the final say on what programs get funded. They have a fairly large change. They can have a fairly large change in the way stuff is moving forward. So a previous director of ARPA-E, Evelyn Wang, was very much an academic. And so science took precedence over impact. Prior to her, it was Lane Dematowski, and his most important metric was commercialization potential. So he would ask questions about bond ratings, which was interesting. And incoming ARPA-E director will probably, Connor Prochaska, will probably have his own bent that he puts on it, but it has a large impact on the agency. And really, the real challenge is that in 2 years, you really don't have a chance to make lasting change. Because you're going to start something, and by the time it gets going, you're leaving.
Yeah, that really, when when you look at the big picture, sounds like a huge problem.
Yeah, I mean, you have your premier, what's supposed to be your premier research agency within, um, within the government, really, spending half of its time waiting for the incoming person. And the incoming person then comes in and spends half of their time trying to figure out what to do, and it's time to leave.
Yeah.
So we in spite of this, we still have very great success, but it could be so much better.
So true. And what would be the model to change this?
I look towards what inspired our program, and that's DARPA. Again, DARPA rapid redeployment of the leadership, so that the leadership needs to change. It happens very quick. And then the other thing they do is they really are very creative with their funding mechanisms and the funding processes that allow them to be, to get programs out the door and funded in a third of the time or less than ARPA-E does.
Wow.
So I think going back to the roots of what DARPA did and taking, and DARPA, they take a high level of risk. And ARPA-E needs to take higher levels of risk, which means protecting bureaucracy.
And we talked a lot, but is there something that we just didn't mention that's worth mentioning?
I guess, people should think about the urgency of what we need to do. We're approaching a period of shortage, in terms of the material sources of our energy. Are becoming, geopolitical issues, are becoming economic issue of how we produce them, and so the urgency of how do we address these. There's a lot of urgency now going into artificial intelligence and quantum computing. But as I tell people, it's really a material world. We do not have artificial energy.
Yeah.
We need real energy to drive all this. And the race for mankind to keep itself going is really based on how urgently we can develop our energy sources, again, in an environmentally, socially, and economically favorable way.
And in this atmosphere, in this global atmosphere, in this political atmosphere, in this, say, scientific and economic atmosphere, do you think we can pull this off? I mean, and not going for the best, possible scenario, but based on the experiences we have, based on, the confidence and abilities we have globally. What do you think? Can we get there on time?
We have to. And as I always say, that I have to have hope.
Yeah.
That we will pull this off. For the next generation. For myself. I'm at a state in life that there's enough energy for me to last out my life.
Yeah.
But I think we're going to have to do this, and I think we can. We have in the past, just taking the U.S. as an example, met huge challenges. there, if you look at, we tend to be blindly bumbling around when world events happen. So leading up to World War II, we were denying we were going to be involved.
Yeah.
We pivoted from being totally unprepared in 1940 to being really, as it's called, the arsenal of democracy. We really produced everything. We came together for the space race, getting to the moon. As a national target that was really independent of politics.
So the difference now, this is actually the global problem. And what I can tell you from my experience, and I've had hundreds of these interviews, I've talked to hundreds of very smart people around the world. I have a feeling, yes, that we can pull it off, but first of all, we are so disconnected. The efforts are in so diverse directions. And I think that the major thing is still the interest, and the capital. So these things has to, we just have to communicate better and put the priorities on the right places.
Yeah, I think educating people to get them out of energy blindness, where it's coming from, a material blindness, is quite important. That's something that's, again, as a scientist, is beyond me. How do we influence society and politics in general in this way? But that's a good challenge for someone who might be listening to this to say, how do we bring everyone together? I look at what I do, mining, and I don't care what your political persuasion is.
Yeah.
Mining is important, and development of the subsurface is important, no matter what you want to do.
Yeah. And no matter where
and nobody
you are.
wants to go out and destroy the environment.
Yeah.
We demonize people and say, "Oh, these guys are intentionally going out to destroy the world." No.
Something fundamental has to change in the way we think and produce things, and the way we think about also recycling and circular economy, energy efficiency. I think two very important topics would be circular economy and energy efficiency.
Well, yeah, and circular economy is, recycling it is. We have to get beyond this good feeling recycling, which is, we throw things in the U.S., we throw it into a blue bin, and we're like, oh, it's taken care of. And actually, I'll say from most analyses, it's better to throw it in the garbage than the blue bin for the environment, because our things are done. But how do we really clearly industrialize our recycling in such a way that, again, treating it the way an oil refinery does, that we just pull everything in and everything gets used on it.
Yeah.
Because the complexity of these things, is so high, that you can't just take it apart and reuse it. It's, you have to break it down to its fundamental atoms almost, bring it back.
Doug, thank you so much for being my guest today. It was an honor talking to you again.
I enjoyed it. I wish you the best, and keep an eye out for what I'm doing. Who knows what kind of rabbit hole I'll be jumping into.
For sure. We'll see each other again.
Okay, take care.